Let's solve this challenging differentiation problem step by step. We'll start with finding y, and then calculate its derivative with respect to x. Our original equation is x raised to the power y equals e raised to the power x minus y. The first step is to take the natural logarithm of both sides to simplify this exponential equation. Using the logarithm property that log of a power equals the power times the log, we get y times ln x equals x minus y times ln e. Since ln e equals 1, this simplifies to y times ln x equals x minus y. Now let's solve for y. First, we'll add y to both sides. Then we can factor out y on the left side. Finally, we can divide both sides by 1 plus ln x to get y by itself. Now that we have y, we can find dy dx using the quotient rule. Remember, the quotient rule states that the derivative of u over v equals v times the derivative of u minus u times the derivative of v all over v squared. In our case, u equals x and v equals 1 plus ln x. The derivative of x is 1, and the derivative of 1 plus ln x is 1 over x. Substituting these into the quotient rule formula, the numerator is 1 plus ln x times 1 minus x times 1 over x. The denominator is 1 plus ln x squared. Simplifying the numerator, 1 plus ln x minus 1 equals ln x. Therefore, our final answer is ln x over 1 plus ln x squared. And that completes our solution. We used logarithm properties to solve for y, and then applied the quotient rule to find dy dx. Thank you for watching.